This is problem number 8 on your Physics LE homework. So we're going to work this out. And so here we go. We've got a football player. All right, he's running 13.9 meters straight down the playing field in 2.5 seconds. He's hit, pushed back, breaks free, runs forward, etc., etc. And you're given the displacement and time for each of those events. And they want you to find his average speed for each of the 3 intervals and then for the entire motion. And they tell you that the positive direction is in the initial direction of the initial motion. Okay? So I don't know any way to do this really without drawing some pictures. You've got to draw a picture. You don't have to be a great artist, and maybe you don't have to draw a picture. You can keep this all straight in your head. But I like to draw pictures, so here we go. Remember, you don't have to exactly be a Michelangelo, was that the guy's name? Painter? He painted the ceiling of some building. So here we go. Football player. This is the American football, right? It's rather brutal, and it causes injuries to brains. So here's this guy. He's going to run in this direction. So that's his initial displacement, delta x. It's 13.9 meters. And that time interval is 2.5 seconds. Okay, so then I'm going to draw just right here. Next, I'm going to go ahead and draw each little part of this all at first, okay? Then I can go back and answer each of the questions separately. So this is for part 1. Then for the second part of the motion, he gets pushed back 3 meters. Yikes. And remember, they tell you that positive is the initial direction of motion for all of these problems. We really need to have a coordinate system telling you what direction is positive and which direction is negative. That just means left or right? North or south, east or west. So just as a reminder here, I want to put plus and a little arrow, and that reminds me that the positive direction is towards the right. That means if he gets pushed back, that his delta x is now negative 3 meters. And the time for that part of the problem was 2.7 seconds. And you may say, wait a second here. He ran 13.9 meters in 2.5 seconds. And then he only gets pushed back 3 meters in 2.7 seconds? Well, that's going to make sense. He's resisting, right, whoever's pushing him. So obviously, the magnitude of the speed during the second part is smaller than the speed during the first part of the motion here, right? Okay, then. Then we could even draw him right here if we want to. Getting pushed back. Yikes. What are you going to do? And there's this big brute pushing him back here. Football, yeah. Okay, then the last part of the problem. He is going to break free. Because he's like right here right now. And run forward another 18.1 meters. So, and this time he ran that 18.1 meters in 5.2 seconds. Okay. So, yay. All right, I don't know if he had the ball or not. presumably he was carrying a football with him, or maybe he was just waiting to catch the football. Projectile motion. And then we want to know the average velocity during each of these parts of the problem here. All right. So for part 1, that V average is going to be the displacement, 13.9 meters, divided by the time interval, 2.5 seconds. Okay, then you need a calculator. Unless you can do this in your head, that's fine. 13.9 meters, 2.5 seconds, 2.5, and divided by, and I get 5.56 meters per second. Your numbers are different from mine. Again, to keep in mind here, the number of significant figures in the answer needs to be the same as the number of significant figures in the problem. And all of these guys have 3 significant figures, okay? If you're not sure about significant figures, you should definitely look at the tutorial for Physics LE. It's a file included with this program up there at the very top before the actual assignments are. You should definitely check out all of those, and then the manual on how to enter answers. So yeah, so there you go. And you type that answer in, and you get a little green check mark. Yay. Okay. Next part. All right, for the next part, okay, so the next part here is what is his average velocity when he's being pushed backwards? All right, so again, for this one, V average is his displacement over time. Sorry, I'm having trouble holding this tablet right. And that's a horrible looking displacement. Let's try this again. The average is there we go, delta x, come on, over t. All right. So then in the problem, it was stated that your delta x was 3 meters in the opposite direction, right? 3 meters in the negative direction, so minus 3 meters, divided by the time it took was 2.7 seconds. Okay, so once again, you get your calculator and you do 3 or negative 3 divided by 2.7. And that gives you negative 1.11 meters per second. All right, and then you type your answer in there, and yay, another little green check mark, okay? Well done. Yeah, you can see here, it tells me that, yikes, what am I only getting 0.95 out of 1? Because, like many people doing these problems, when I entered in this answer the first time, I forgot to include the negative sign. So yeah, they dock you, okay, for that. But it's no biggie, right? You go back and re-enter it with the correct sign, and everything is good, okay? That's why you're allowed multiple attempts to enter in these answers, all right? You keep trying, and you try, and you try, right? And eventually you'll get it right, and it'll feel so good. Okay, then the last part, or the second to the last part of the problem is part 3. So what is this average speed for the third part? So we'll just go over here. So for the last part, they tell you that he escapes and then he runs 18.1 meters. And the time that it takes him for this last run is 1 How much time does it take him? I don't know. Let me go back here and look. 5.2 seconds. All right, so 18.1. And then 5.2. And that gives me 3.48 meters per second. And then is that right or not? Let's check and see. Hold on. Yep, check it out, yo. That was correct. And then the last part is they want to know the average velocity for the entire motion. Okay. So you might think you could just take the average of these three velocities to get the overall average velocity, but that's not how average velocity works in kinematics. Okay, the average velocity is just, once again, it is the total displacement divided by the total time. So for the last part, for the entire motion, we're just going to... Okay, so for the final part of the problem, final V average. Let's see, so you went 13.9 meters this way. Then you went 3 meters in the opposite direction. Then you went 18.1 meters, again in the original direction. Okay, and so your total displacement, your total delta x, is 13.9 meters minus 3 meters plus 18.1 meters. So then your total displacement is 29 meters. Okay, now then you need to divide that by the total time. So for the first part of the motion, the time was 2.5 seconds. Then for the next part of the motion, the time was 2.7 seconds. And then the final time interval was 5.2 seconds. All right, so then the total time was calculator in hand here somewhere. There we go. 2.5 plus 2.7 plus 5.2. So that gives you 10.4 seconds for the total time. All right, and then 2.9 divided by 10.4. Sorry, 29 divided by 10.4. 2.79 meters per second is your overall average speed. All right, and is that? There it is. Yay. Okay, so there you go. It's another interesting thing here you might have noticed is that the displacement here can be positive or negative. That's why we did, 13.9 minus 3 plus 18.1. But for the times, you add them all up. So there are no negative times. That seems interesting if you think about it. Why can displacements in space be negative, but displacements in time are not allowed to be negative? Okay? Space, time. These are fundamental concepts, right, in physics. Actually, it's just in the way the world works, period. Everything takes place someplace in space, right? Space. And everything takes place when in time, right? But there seems to be some differences in the way we talk about space from the way we talk about time. So again, these are fundamental ideas in physics and in science and in the way that the world works. And it's really good to think about these things. All right. Some of the most major breakthroughs in the way we think about space and time in the universe come from asking the very simplest questions. Right? What is the nature of space? And why can't time go backwards? Okay. And little kids, okay, seem to ask a lot of questions like this. All right. So everybody is born a natural scientist and philosopher. And some people retain that curiosity throughout their lives. The most notable figure is probably Albert Einstein. He asked the simplest questions since he was a little kid. And he asked those simple questions throughout his life. And, yeah. So, simple things. I know this may not seem simple to you, but it's physics and motion and velocities. But if you think about it, pretty much for this first, 2 or 3 months of school, we're only asking questions about space, which you measure with a ruler. Space. Doesn't have to be outer space. There's space right in front of you. The space between your ears, okay? And then the other quantity that we measure is time. And you do that with a stopwatch here. Or, we can use our phones in class to measure time. Yay. You can also use your phones to measure distance now. Anyway, so there we go. That was problem number 8, and we'll talk more about that tomorrow in class. All right, have a good night.